Alternate current AC. Alternating current and voltage means the voltage or current whose magnitude changes with time is called AC. It has both negative and positive values. The time taken to complete one cycle of variation is called the time period. Means the voltage of current the whose magnitude changes with time is called alternating current. Alternating means changing, like that the voltage or current whose magnitude will be changed with time is called AC, and it has both negative and positive values. The time taken to complete one cycle of variation is called time period, and after every time period the value and direction will repeat. And graphical representation of sinusoidal and triangular and rectangular complex. Next one is direct current means DC. If the magnitude and direction of current do not change with time is called DC. In alternating current the magnitude of voltage or current will change with time, but direct current the magnitude of voltage or current will not change with time is called direct current. And current drawn from a cell is an example of DC. And frequency of DC is 0. It is very important. Frequency of DC always 0. And variation of DC with time is a straight line parallel to time axis. It is a graph. Means variation of DC with time is directly proportional to the variation of DC, and the graph is straight line. And definitions used in AC circuits. First one is instantaneous value. The value of current or voltage at any instant of time in an AC circuit means if for example a current changes from 5 ampere to 30 ampere in 30 seconds, we have to know how much current will change in at particular instant of time, like 5 seconds to 10 seconds. Like that the value of current or voltage at any instant of time in an AC circuit is called instantaneous value. Means at 5 second to 10 second how much current will change, like that we have to find the value of current or voltage at any instant of time is called instantaneous value. And sinusoidal AC. Sinusoidal AC is represented by graphically means this one, and represented by I is equals to I naught sin omega t, or E is equals to E naught sin omega t. Amplitude means maximum or peak value of alternate current. And time period, time taken to complete one cycle. And frequency, number of cycles completed in 1 second, f is equals to 1 by t. And angular frequency, omega is equals to 2 pi f. Frequency means 1 by t. We can write it also omega is equals to 2 pi by t. And theta by t means angular frequency means rate of change of angular displacement. And some important relations, f is equals to 1 by t, omega is equals to 2 pi f is equals to 2 pi by t, and t is equals to 1 by f. And amplitude of AC means the maximum value of AC is defined as amplitude or peak value. The value of AC becomes maximum twice in one cycle. Amplitude of AC means the maximum value of AC is defined as amplitude or peak value. The value of AC becomes maximum twice in one cycle. And time period of AC. The time during which AC completes one cycle is defined as time period. Unit of time period is seconds. And frequency of AC. The number of cycles completed by AC in 1 second is called frequency. F is equals to 1 by t hertz. Its value is equals to the number of rotations made by a coil in magnetic field in 1 second. In India, AC frequency is equals to 50 Hz. It means current flows 50 times in one direction and 50 times in the opposite direction in 1 second. And angular frequency. Angular frequency means the rate of change of angular displacement. The frequency of AC used in houses is equals to 50 Hz. Omega is equals to 2 pi by T is equals to 2 pi F. F means frequency. 1 by T is equals to frequency. And key points. AC changes its magnitude and direction with time. AC has both positive and negative values. DC is constant and unidirectional. And frequency, time period, and omega are related as above. Alternate current means AC changes its magnitude and direction periodically. And average value of sinusoidal AC over one full cycle, average value is equals to 0. And average is always taken over a half cycle. It is positive or negative. And type of cycle average value is given here. Full cycle means average value is equals to 0. Positive half cycle means 2 I naught by 5, and negative half cycle means minus 2 I naught by 5. I naught means peak value. For symmetric AC, average over full cycle is 0. And important relations, if I is equals to A sin theta, then I max is equals to A. And if I is equals to A plus B sin theta, then I max is equals to A plus B. If A comma B are greater than 0. And if I is equals to A sin theta plus B cos theta, then I max is equals to root over A square plus B square. And if I is equals to A sin square theta, then I max is equals to A. And RMS means effective value of AC. It is that value of DC which would produce a same heat in a given resistance in a given time is done by the AC. And for sinusoidal current, I is equals to I naught sin omega t. IRMS means I naught by root 2. RMS means root of mean of square, and IRMS is equals to I naught by root 2. If VRMS means VRMS is equals to V naught by root 2. And finally, if we divide both means ratio of IRMS by VRMS is equals to I naught by V naught. And next one is RMS value for different currents. Current I1 is equals to I naught sin omega t, average value is equals to 0, and peak value is equals to I naught, RMS value is equals to I naught by root 2, and angular frequency equal to omega. And I2, if I2 is equals to I naught sin omega t cos omega t, means we can write it as sin omega t and cos omega t sin 2 omega t by 2, means sin 2 omega t by 2. Sin 2 theta formula sin theta in 2 sin theta cos theta, like that sin omega t cos omega t is equals to sin 2 omega t by 2. We can write it as I naught by 2 sin 2 omega t. Average value is equals to 0, peak value is equals to I naught by 2, RMS value is equals to I naught by 2 root 2, and frequency is equals to 2 omega, means angular frequency is equals to 2 omega. And I3 is equals to I naught sin omega t plus I naught cos omega t, then average value is equals to 0, and peak value is equals to root 2 I naught, and RMS value is equals to I naught. Angular frequency is equals to omega. And for all the above, peak value is equals to RMS value into root 2. Means if we multiply I naught by root 2 into root 2, we get I naught. In the case of I1 is equals to I naught sin omega t. Like that we have to get peak value, means we have to multiply root 2 with RMS value. Then we can get I naught by 2 as a peak value and root 2 I naught as peak value. And next one is average value of alternating voltage. E is equals to E naught sin omega t, where E is equals to instantaneous value of voltage and E naught is equals to peak value of voltage. Mean value over half cycle is equals to E average is equals to 2 E naught by pi. And root mean square value also E naught by root 2. and mean value over full cycle is equals to 0. And next one is AC circuit containing pure inductor. And next one is measurement of AC. DC ammeter and voltmeter are based on the principle of torque acting on a moving coil placed in a magnetic field. Hence, it cannot be used for AC. An AC measuring device should not depend on the direction of current, and hot wire ammeters and voltmeters are used for this purpose. Um, Hot wire instruments are based on heating effect of current. These devices give the RMS values of the alternating voltage and current. The scale of AC instruments is not linear as in DC instruments. In hot wires, the instrument's deflection is related to RMS value of current, as theta is directly proportional to I square. Hot wire instruments can measure DC quantities also. If AC is produced by generator having large number of poles, then frequency of EMS is equals to frequency of rotation per second by 2. Means AC measuring device should not depend on direction of current, and hot wires instruments and based on heating effect, and theta is directly proportional to IRMS value square, and frequency of EMS is equals to F by 2. Mhm. And LC converter circuit is used to convert AC into DC. This one also important. LC converter circuit is used to convert AC into DC. DC meter in AC circuit leads 0 because average value of AC is 0 for complete cycle, while AC meter works for both AC and DC circuit. It is next topic is there. And next one is terms DC meter, AC meter. Name moving coil and hot wire based on magnetic effect of current, it reads average value, and hot wire based on heating effect of current, it reads RMS value. Means RMS value is RMS value means AC meter means hot wire based on heating effect of current, it reads RMS value. And next one is advantages of AC. Means AC is cheaper than DC, and it can be easily stepped up or stepped down with the help of transformer. It can be continuously varied over long distances at negligible power loss. It can be transmitted over long distances at negligible loss, and it can be stepped up or stepped down with the help of transformer, and it can be controlled easily, and it can be transmitted over long distance at negligible power loss also. Means in this power loss is very less. And next one important points means AC can't be used in charging of large capacitors, as its average value is 0. Means average value is equal to 0 means we cannot use AC charging of large capacitors. The operation of electrolytic devices. In the operation of electrolytic devices also we can't use AC, because due to large inertia, ions cannot follow the frequency of AC. Electrolysis of electroplating means their large inertia will be there, so ions cannot be follow the frequency. It is not electrolytic devices, it means electroplating. Okay. Next one is the rate of change of AC is minimum at the instant when it's near its peak value, and maximum at instant where it is 0. Means rate of change of AC minimum when means when it is near its peak value. Means peak value is equals to rate of change of AC, means then rate of change of AC is equals AC is minimum. If rate of change of AC is maximum means when when it is 0. Means the rate of change of AC is minimum at that instant when it's near its peak value, and maximum at that instant when it is 0. And for alternating current, I naught is greater than IRM is greater than I average. Sorry, that is not aliphatic. It is IRM. I naught is greater than IRM is greater than I average. And average value of over half cycle is 0 if one quarter is positive and another quarter is negative. Generally, average value of one cycle is 0. If average value of over half cycle is 0 means one quarter is positive, another is negative. And next one is average value of symmetrical AC for cycle is 0. Always average value of symmetrical AC for a cycle. A complete cycle is 0. That's why average potential difference on any element in AC circuit is 0. Means average potential difference on any element in AC circuits means 0. Okay, average value of cycle is 0 if one quarter is positive and another is negative. And symmetrical AC means for a cycle 0. Next one is the instrument based on heating effect. Okay, heating effect of current works on both AC and DC. Supply and provides same heating for same value of AC, RMS and DC. That's why a bulb glows equally in DC and AC of same value. Okay, and the frequency of AC is F, then becomes 0 2 times in 1 second, and the direction of current changes 2 F times in 1 second, and it becomes maximum 2 F times in 1 second. Okay, frequency of AC becomes 0 2F times in 1 second, direction of the current changes 2F times in 1 second and become maximum 2F times in 1 second. And area under IT graph and time axis gives charge. Okay, area under positive cycle is equals to area under negative cycle. The total area under complete cycle is 0. Total area also 0. If one area is positive another area is negative means total area is equals to 0. And next one is AC circuit containing pure inductor and capacitor. Inductive reactance means inductor offers opposition to AC called inductive reactance. It depends on inductance L and frequency F. XL is directly proportional to omega L is directly proportional to 2 pi FL, where omega is 2 pi FL is the inductance. SI unit is Henry. And some important points means as F is equals to 0 in DC, XL is equals to 0. Inductor acts as a short circuit. If F is equals to 0, that inductor acts as short circuit. And if F is equals to infinite, then XL is equals to infinity. Inductor acts as an open circuit. For IRF or IRL, inductive reactance will be increases. And this is the graph. And phasor relation means in this inductor voltage leads current by 90 degree or current lags behind the voltage by 90 degree. In inductor voltage lead the current by 90 degree and current lag the voltage by 90 degree. And one example means an inductor of L is equals to 0.5 Henry is connected to AC of frequency 58. Then find XL. XL means they already given frequency, they given L values. Then we can find it by using a formula. XL is equals to 2 pi FL, that equal to 2 pi into 50 into 0.5, approximately equal to 157 ohm. And next one is capacitive reactance. Capacitor offers opposition to AC called capacitive reactance. It depends on capacitance and frequency F. X is equals to 1 by omega C is equals to 1 by 2 pi FC, where omega is equals to 2 pi F angular frequency. Important points: as f is equals to 0 in DC, xc is equals to infinity. Means we substitute in the place of 2 pi, in the place of f we get 1 by 0. 1 by 0 means infinity. Then it is act as a capacitor, act as a open circuit. Mm. We already seen in inductor, uh, as f is equals to 0, xl is equals to 0. Then it is act as short circuit. Means xl xc is equals to infinity, means it acts as open circuit. And f is equals to infinity, then xc is equals to 0, then capacitor acts as short circuit. uh, since it is inverse proportional for higher f and higher c, xc obviously decreases. In this phasor relation means voltage lag behind the current by 90 degree, current lead the voltage by 90 degree. And a capacitor of C is equals to 100 microfarad is connected to AC, F is equals to 50 Hz. Then find XC. XC is equals to 1, we know 1 by 2 pi FC. If we substitute F is equals to 50, means the capacitance is equals to 100 into 10 power minus 6, means we can get approximately 31.8 ohm. And next one is feature inductor and capacitor comparison. Reactance is there, means xl is equals to omega l. Capacitor means xc is equals to 1 by omega c. Phasor relation: current, voltage lead the current by 90 degree in inductor, and current lead the voltage by 90 degree in capacitor. As f is equals to 0 means inductor is equals to 0, capacitor means infinity. If xl is equals to 0 means short circuit, xc is equals to infinity means open circuit. At f is equals to infinity means xl is equals to infinity, xc is equals to 0. Effect of frequency means increases with f, decreases with f in capacitor. And next one is comparative study of purely resistive, capacitive and inductive circuit. um, Circuit resistivity circuit means R is there, and inductive means L, capacitance means C. And supply voltage V is equals to V naught sin omega t, V is equals to V naught sin omega t. In the case of capacitor also V is equals to V naught sin omega t. In three cases also voltage is same. And current, in current resistive circuit means I is equals to I naught sin omega t, there is no phase difference is equals to 0. Inductive circuit means I is equals to I naught sin omega t minus pi by 2. In this means voltage lead the current, and capacitor means I is equals to I naught sin omega t plus pi by 2. In both the cases also phase difference is equals to pi by 2. And peak current, I is equals to I naught is equals to V naught by R. In the case of inductive means I naught is equals to V naught by omega L, and capacitance means uh, 1 by simply V naught omega C. And impedance also equal, but V naught by I naught is equals to resistance, V naught by I naught is equals to omega L is equals to inductive reactance, and V naught by I naught is equals to 1 by omega C is equals to capacitive reactance. And phase difference I already said 0, pi by 2 and minus pi by 2. Graph is important. In phasor diagram there is no phase difference in resistive circuit. Yes, both are parallel. And inductive circuit means current 90 degree difference is there. And next one is LCR series circuit, means AC circuit. And it is circuit diagram. In this resistance also there, uh, inductance also there, capacitor also there, and phasor diagram also there. mm, VL minus VC, Y means VL is greater than VC, we can observe it in diagram also. Next one is applied voltage. E naught is equals to VL minus VC. VL is equals to I naught XL, as V is equals to IR according to Ohm's law. In the place of R we can substitute as XL, inductive reactance. And we can substitute in the place of VL, then we get E naught is equals to I naught into XL minus XC, means Vc is equals to I naught XC. If we substitute both the values, we can get it I naught as common, and we can get E naught into XL minus XC. And next one is reactance. Reactance is X is equals to E naught by I naught. E naught means nothing but voltage only, where X is equals to XL minus XC, or X is equals to omega L minus 1 by omega C, means reactance omega L and capacitor reactance 1 by omega C. And phase relation, if omega is less than 1 by omega C, or omega is less than 1 by root LC, means omega uh, and the circuit is capacitive. uh, Phi is equals to minus pi by 2, because current voltage lags current by pi by 2. If omega L is greater than 1 by omega C, or omega is greater than 1 by root LC, means circuit is inductive. Phi is equals to 1 pi by 2. Current voltage lead the current by pi by 2. And in important points means phase difference between inductive reactance and capacitive reactance is pi, means we will minus both the values, then we get pi by 2 minus of minus pi by 2, then we get pi. Okay, inductor is called low pass filter and capacitor is called high pass filter. Why we call inductor is called low pass filter, means it allows low frequency signal to pass. Capacitor is called high pass filter because it allows high frequency of signal to pass. D circuit to AC is called impedance. Z is equals to E naught by I naught. We denote impedance as Z, and it is equals to root of R square plus XL minus XC whole square, where XL is equals to omega L, XC is equals to 1 by omega C. Also omega is equals to 2 pi F. And VR is equals to in phase with I. VL means lead current by 90, VC lag current by 90. E is equals to resultant. If VL is greater than VC, means E leads the current by 5 phase difference. VC is greater than VL means current leads the voltage. And maximum peak value voltage is equals to E naught is equals to VR square plus VL minus VC square is equals to I naught into R square plus XL minus XC whole square. As V is equals to IR, V is equals to IXL, V is equals to IXC, where XL, XC are the inductive reactance and capacitive reactance respectively. And phase difference between EMF and current. Tan phi is equals to XL minus XC by R is equals to omega L minus 1 by omega C by R. If XL is greater than XC, phi is positive and E leads the current, and XC is greater than XL, pi is negative and I leads the current. And one example means if XL is equals to 50 ohm, XC is equals to 30 ohm, R is equals to 40 ohm, then we can find Z as by using this formula. R square plus XL minus XC whole square under root, then we can get 20 root 5 ohm. And next one is series resonance in LCR series circuit. At resonance, XL is equals to XC, VL is equals to VC, and phi is equals to 0, E and I in same phase. Z minimum is equals to R, impedance is minimum. I max is equals to E naught by R, circuit is maximum. E naught is equals to VR, where XL is equals to inductive reactance, XC is equals to capacitive reactance, Z is equals to impedance, R is equals to resistance. That's all. And resonance frequency, XL is equals to XC. If we can substitute, means we will get omega is equals to 1 by root LC And also frequency is equals to 1 by 2 pi L root LC, means omega is equals to 2 pi f. Then we can shift to 2 pi in numerator. Variation of Z with frequency. If f is less than fr, then xl is less than xc, and pi is negative. Circuit nature is capacitive, and f is equals to fr, then xl is equals to xc, and circuit nature is resistive, and phi is 0. F is greater than fr, then xl is greater than xc, and phi is positive. Circuit nature is inductive. And graph means as f increases, z first decrease and then increase. And variation with frequency, as f is equals to current is maximum, I max is equals to v by r is equals to e naught by r. At frequencies away from frequency and current decreases. And this one is graph. At resonance, xl is equals to xc, z is equals to r minimum, I is maximum, and in phase with e. Transformer short notes. Definition of transformer means a transformer is a static device that transfers AC power from one circuit to another by mutual induction at the same frequency. And principle, it works on the principle of mutual induction. AC in primary coil produces alternating flux in the core, which links the secondary coil and induces EMF. Types of transformers means there are two types: step up and step down transformer. Step up means Vs is greater than Vp, means voltage of secondary coil is greater than voltage of primary coil. Then number of number of turns in secondary coil is greater than number of turns in primary coil. Then soft iron core is placed in between primary coil and secondary coil. It increases the number of flux. And step down transformer means number of turns in secondary coil is less than number of turns in primary coil. Current is less than primary coil is less than current in secondary coil. Voltage in secondary coil is less than voltage in primary coil. It is called step down transformer. And ideal transformer relations means voltage ratio is equals to Vp by Vs. Primary voltage by secondary voltage is equals to primary number of coils by secondary number of turns is equals to 1 by k. And current ratio is equals to Ip by Is is equals to Ns by Np is equals to k. And power is equals to V I is equals to primary coil voltage into primary coil current is equals to secondary coil voltage into secondary coil current. Impedance ratio is equals to Np by Ns whole square. And efficiency eta is equals to output power by input power into 100%. Means secondary coil voltage into secondary coil current divided by primary coil voltage into primary coil current into 100. And advantages means it is high efficiency and can step up or step down voltage used for transmission of distribution of AC power. And disadvantages means works only on AC and there are losses.